Hello, everybody. Happy Friday, wherever you are, and welcome to TGI Kubernetes. I'm your host for the day, Joe Beta. I'm a principal engineer here at VMware. And TGI Kubernetes, for those who are new or not familiar, is a weekly-ish live stream that we do, either me or Duffy or sometimes a few other folks, where we just explore things in the Kubernetes world. Sometimes it's something we know really well that we go deep on and kind of do an in-depth sort of demo and lesson around. Other times we're learning things for ourselves new, and so we sort of take people along for the journey with us as we figure out, the ins and outs of something new in the Kubernetes ecosystem. So that's what we're doing. And I would like to start by saying hello to everybody in the chat that's joining us. We have Chaim from Israel. Good to see you. Rodolfo, good to see you. Lamati, who's always with us, saying happy sysadmin days to the ops folks out there. Tim is ready to scale. Liam in the UK, good to see you. Ivan. Martin from the Netherlands. Awesome. Okay, I'm gonna Bojank Honk. I don't know how to pronounce that, but hello and welcome. Sevi from Istanbul. Fully Geared Bear. Igor from Moscow. Tim. Joy from Richmond, Virginia. Alex from Atlanta. Sandeep from Poland. Ismail from Turkey, Arun from India. Oh, my t-shirt, Liam's talking. So this is an old school t-shirt. This was like one of the old school threadless t-shirts back when they were doing some really interesting stuff. And I knew I was doing TGIK today, so I'm like, I'm going to dig deep into the drawer and grab something I haven't worn in forever. So here we go. This is from the archives. Philippe from Paris, good to see you. Vivian from Munich. Paul from St. Louis. Yatin. Sebastian from Hungary. It's a hard no worries. Okay, thank you. And then Mads from Denmark. I want to get started. I love seeing everybody coming from all over the world, dealing with the absolute horrible time. Every time I apologize, but we never change the time. It's like evening or morning in other parts of the world. So this is probably worldwide the worst time. But it's nice to do it for me, at least on the West Coast here of the US, where we see sort of the week winding down. It's a good way to end up the week. All right, let me go ahead and jump in and get started. We usually start out here. There we go. We usually start out here by going through, and we have a bunch of sort of news from around Kubernetes, the Kubernetes ecosystem, and the cloud native ecosystem in general. And Duffy saying hi here. That we go through. Now, this is on a shared document using this awesome service called HackMD. You can get to it with, let's see, http tgik.io/notes if you want to join in here. And so what would be really helpful is like keeping the time codes. I copy and paste those into the archive video, and that ends up creating sort of chapter marks. They added that to YouTube a little while ago, which is super cool. Or if there's other notes or impressions or things that you want to add, feel free to add them to the doc here. So we'll just crowdsource this. All right. Let's go through. So we break these things into sort of core Kubernetes stuff, what's going on. And what we're seeing here is that the 1.19 release cycle is marching forward. I don't think that there's anything sort of groundbreaking coming in 1.19. I think, we see it's being built on the latest version of Go. You can check out the changelog there. As it gets released, we'll definitely go through and do a review, a more in-depth review. I think that might be a good episode. Maybe we want to start like, hey, as a new version of Kubernetes comes out, we actually spend quite a bit of time just digging into the details there. That might be good. Let's see, Sig Multi-Cluster. I was doing a sort of crowdsourcing to name some of the stuff that they're doing. So cluster set is the proper name for a set of clusters. Very creative. But other stuff was cluster pool, cluster fleet, and cluster array. This is for being able to actually sort of view a set of clusters. It's a separate sort of layer from something like Cluster API, which is about driving the creation of clusters. But I bet you can use these things together, which would be really interesting. let's see, Duffy's putting in the chat here, but those that are involved and deeper in the community, a lot of the stuff for KubeCon is getting wrapped up right now in terms of pre-recording and getting that stuff all settled. And so I know a lot of folks have been heads down, stressed out over that, Duffy included, which is one of the reasons why we're giving him the afternoon off here so that he can actually finish that stuff up. And then another really important thing in the Kubernetes world is the Code of Conduct Committee, and that election process is underway. And, you know, when I was on the steering committee, this was a really interesting thing because everybody agrees that you should have a code of conduct, or at least I think most people do. It is a controversial topic in a lot of ways. But when you get down to the brass tacks of how do you actually enforce a code of conduct, because with a community as large as Kubernetes, you're going to have things come up. You're going to have conflicts. And, you know, we wanted to make sure that we were thoughtful in terms of the folks that were actually making these very important decisions of evaluating, you know, what's going on and what the right things to do to protect the community and protect folks in the community. And so this is something where folks from across the community get involved. There's an election to make sure that they represent, you know, how the community actually views this stuff. And so I think this is a really interesting thing. I'm not that familiar with that many open source projects that actually have sort of gone down that path about not just having a code of conduct, but really getting into the details of how you enforce it. So some really interesting stuff there. Waleed, good to see you. This is TGIK Hex 7E. Yeah, 128 is going to be a big one, right? That's going to be TGIK 80. That's almost like TGIK 100. All right. So other stuff from around the ecosystem. Monica here put together this great set of changes for the CKA exam with a great chart that actually shows, you know, where some of the emphasis and how they're breaking it down. And what I think is really fascinating here is that this exam has evolved. And I think, you know, from what I've seen, I've not taken it, so y'all know more about Kubernetes than I do. But from what I've seen, it's been evolving to actually be more and more realistic, more and more useful. And I really like what I see here in terms of, you know, the way that they're breaking down the topics in the mix here. I think like a big experience on troubleshooting, just, you know, being able to understand how the system works. And then things like security, instead of having that be a separate thing, having that really be threaded through and sort of be an ambient thing across everything that's happening in the exam. So I think that's really interesting. And so, yeah, a lot of great detail here in terms of the changes that are coming if you are interested in getting that certification. So thank you, Monica, for that. Okay, so here's a blog post. I didn't do this, but Sean here did. Made a Kubernetes game where you explore your clusters and destroy pods. I always think this stuff is fun because, you know, there's folks who have adapted Kubernetes and, you know, representing that into Minecraft and such, but here this person actually wrote a game from scratch using Unity, and then targets it at his Raspberry Pi cluster. And so, you know, as you have this little spaceship thing, you can actually shoot and destroy the pods. They have hit points, and then when you actually delete them, they actually disappear. And then there's a node that you can enter. I don't know. It's really interesting. Super fun stuff. I need to find some time to download it and give it a try. Probably a great way to learn Unity and Kubernetes at the same time. All right, this is really cool. George pointed me to this, and this is a video which you can't hear. And we have an ad that's going to play here. But this is a skip the ad. So this is a review of this thing called the Turing Pi. And so what happens is that a lot of folks build a Raspberry Pi cluster as a way to play with Kubernetes. And I think it's actually really interesting as we see more stuff happening with ARMs, whether it be with ARM, whether it be AWS, or whether it be things like, you know, Apple moving to their own silicon. It's pretty clear that ARM is getting more and more into the mainstream. And so I think it's going to be much, much easier as we may go down this route to actually use a Raspberry Pi cluster as being something that becomes more accessible for people that want to do home labs type of stuff, and more applicable in terms of representing the types of things that you might see in production. The fascinating thing here is that, here's a good image of it, is that what this is it's essentially a backplane so kind of a motherboard, and into the motherboard you can actually plug a whole bunch of these Raspberry Pi compute modules, which use a DIMM slot to be able to actually connect in. And then it has essentially a built-in gigabit switch, I believe, and one power cable. So instead of Velcroing things together, you can actually use this to create an environment. And so I haven't actually watched the series. I need to find the time, but George was saying that he watched it, and Jeff here actually goes through this as a multi-series review, including running and installing Kubernetes on these things. So that I think is super, super cool. All right, I got to catch up with the chat here a little bit. Let's see. Oh man, you all are chatting with each other. You don't need me. Let's see. Oh, Lamatti was asking about my oscilloscope. Okay, I don't have it here. I had it upstairs. Like that's a toy, because in the other thing that I've been playing with, and this is a tangent, and is I want to get into synthesizers. So I just picked this up yesterday. This is a Moog Mother 32. It's a semi-modular synth. And as I've been learning more and more about the synthesizer world, I want to like explore the hardware there. But I also think that the way you plug them together and the sort of composability of modular synthesizers is probably a good comparison, or at least a good way to talk about the way that we compose together things in the Kubernetes world. And so maybe that's something I'll write a blog post or do a TGIK on at some point. I think that would be a lot of fun. So that's what's up with the oscilloscope. I got it to be able to play with this stuff, and maybe start writing my own modules for a modular synth. All right, let's keep moving. Too much stuff to cover. New sandbox project called Chaos Mesh. This looks really interesting. I haven't heard about this before, so this might be something fun to do an episode on. It's essentially a platform for thinking about doing all sorts of different types of chaos engineering things, like, killing pods, doing clock skew, corrupting the network. These are fascinating, because a lot of times we think about failure in these systems as like, well, a power supply blows up and the machine catches on fire and that node disappears. And that's a pretty clean failure. But I think in reality, when you start dealing with sort of hardware, it may be that, certain port on your network switch actually sort of corrupts at a certain bit pattern of a packet. And so there's this subtle sort of degradation that you see, and building systems that are resilient in the face of those sort of like semi-failures is really, really, really hard. And so I love the idea of having a whole set of tools to be able to simulate those things, so that we can make our infrastructure and applications that much more resilient. So it looks like a super cool project. That would be a good TGIK episode there. All right, Ryan Miller here has a blog post on writing a CRD and a controller with KubeBuilder. So this one's actually complete, unlike that Minecraft controller that I started but never actually finished off. So this looks like some really interesting sort of, quick intro here. Super cool. Check that out. And then finally, Brian talks about 2 quick ways to apply zero trust to Kubernetes. And so zero trust is this idea that it's really defense in depth around like, hey, I don't want to, like, a lot of security in the data center world is what I call sort of the hard outer shell, soft GUI center model of security, where it's like you have a bunch of firewalls and, oh, I missed KVDI. I'll go back to that. We have a bunch of firewalls and you have sort of a secure perimeter, but then everything's loosey-goosey on the inside. One of the things that we're moving forward with, and I think the world is moving forward with at a bunch of different layers, is this idea of zero trust, where it's not just about like having that hard outer shell. You still want to have that, but you want to have this defense in depth where you actually have limited trust across all the different things, where it's like, hey, I want to run a bunch of stuff, and what if somebody's tapping my network? What if my network's not secure? How do I deal with that? And in the desktop sort of like corporate network world, this is like beyond corp, this idea that the idea of a VPN is really an antiquated concept, because that VPN is that hard outer shell. You really want to make sure that, like, hey, if somebody's desktop gets compromised, you actually, and they have access to your VPN, you actually have the internal controls inside of that environment to be able to still be resilient. And that applies both in terms of a corporate network, but also in terms of a production network. And so network policies are one way to actually start saying, hey, if something gets compromised, let's ring fence it. And then something like Spiffy, and we did a TGIK on Spiffy and Spire. I think there's probably more to be done there. Is a way to essentially automatically manage TLS credentials to be able to handle identity. You'll also get some of this stuff along the way with things like service meshes. And so those interesting blog posts that actually starts to dig into some of this stuff. All right, and then finally, the one I skipped over here is KVDI. So this is fascinating. So this is a virtual desktop infrastructure is this idea that people can walk up and say, give me a desktop that I can remote into. And then I can have sort of that desktop experience, but it's hosted in the cloud and it moves with me. And so oftentimes, this will be Windows with things like Terminal Server, and Amazon has one that's with Windows. Here's somebody who built Tiny Zimmer that built this on top of Kubernetes using a controller. And technology-wise, what this is it's actually not running a full VM. It's actually running essentially an independent X Windows desktop using tiny VNC and stuff like that. So it's not actually running a full desktop. It's actually running a sort of a containerized desktop, which is super interesting. And then it runs these things in pods. And I think what's really fascinating is that they've gone super deep in terms of modeling out the different roles, who gets access to what, when, and where, and all of the sort of policy stuff that you want to layer on top of this, which I think is really cool, combined with the fact that they're not doing virtualization. So initially when I saw this, I thought it was really about running something like QEMU or KVM, which is similar to something like KubeVirt. But this is actually using raw Kubernetes, raw containers to be able to do this stuff. So really interesting looking project there. All right, Steve's asking, what about my t-shirt here? I'll switch back to the big camera. It says, haikus are easy, but sometimes they don't make sense. Refrigerator. This is my this is one from the archives. It's been a long time. Okay, Kim's asking, anything exciting? The link didn't come through for the t-shirt. I wonder what's going on there. Oh, it just doesn't show on the screen there. Okay, cool. Yeah, I was on Threadless. What's happening in the GitOps world? The latest, and I had a chance to catch up with Lucas, who's doing a summer internship for Weaveworks, is that there's this GitOps toolkit that I think is really interesting. And I was pointing him and hooking him up with the folks working on K14S, which I've also done an episode on. But the idea here is, instead of viewing GitOps as a singular system, view GitOps as a set of building blocks that you can compose together to be able to do things. And so some of these things are like separating out, hey, I want to apply something. It could come from Git, but could also come from some other system of record and being able to apply it there. And then also having, notifications be decoupled. And then one of the things that's in flux is this ability to actually sort of modify things the other way. Notice when a new image gets pushed to a registry, and then hooking that around and modifying the core YAML that's actually drawing things to be able to yeah, that's it. Yeah. To be able to actually do that. Yeah. And so that's, and there's some sort of, integration with Helm, customize. But I was talking to Lucas of hey, is there sort of a more general, even more decomposed model that we can bring here? So really interesting to see this stuff happen. Yeah. So the toolkit, so there was going to be a merge between Argo and Flux. I don't know the current status of that, to be honest. I think this was part of the plan there. I'm just not sure where it's at right now. All right, I don't want to take too much time before we get to our real. Oh, it is not happening. Okay. Yeah, I don't know. I haven't been involved in that, so I'm not quite sure what the latest is around that. And then this is a move in that direction. Okay, cool. Yeah, we envision where Flux v2 and the Helm operator will be assembled from the GitOps toolkit. Yeah, and so I think that componentized view of having a bunch of pieces that you pull together, I really like seeing that, and I think it's great to see, you know, the GitOps toolkit move in that direction. I think it's compatible with some of the other things that, you know, we've been looking at through things like K14S in terms of breaking this stuff down. All right, so that is that. All right, so let's take a let's transition to actually talking about the topic du jour of the day, which is the link to the HackMD page is always tgik.io/live. /notes is where it's at. So we should have, you know what I'm going to do? I'll tell you what is, I'm going to modify my OBS setup for future TGIKs where I actually have the link to tgik.io/notes up there so that folks can find it. I think that'll be a useful way to make sure that it's always there. Because that's, yeah. Okay, cool. So what we're going to be talking about today is vertical pod autoscaling. And this is different from when we usually talk about autoscaling. There's really three different levels that we talk about. Most of the time we're talking about horizontal pod autoscaling. And what that means is that, let's say that you're using a deployment, what you want to do is based on some criteria of load, you want to be able to adjust and turn the dials in terms of the number of replicas in that deployment. We all know that with Kubernetes, you can always walk up to a deployment and change the number of replicas. And as you do that, it automatically causes new pods to be created or pods to actually be deleted. But how do you know when you want to change it? Well, you can be like, hey, I got a page and the site's down because it's overloaded. Let me go ahead and actually increase the number of replicas. Or you could have a system that does that for you. That's horizontal pod autoscaling. And that's really a technique to deal with unpredictable amounts of load coming into an application. If you do have predictable, even if it's not constant, I think that there's probably techniques that you can do to essentially adjust the size, the number of replicas you have, say, based on time of day, right? And that'll actually be a much simpler thing for you to wrap your head around. Many services, almost every service has what we call a diurnal cycle, where you can actually look at the graphs in terms of the number of requests per second or the amount of load, and it follows a very predictable cycle with something like, you know, hey, on the weekends we either have more or less, that type of thing. But oftentimes you'll have that, and then it'll be augmented with, like, say, an event like we're doing a big launch, or we hit the front page of a social media site or something, in which case you're going to have very unpredictable load. And in that case, you want the system that can automatically scale up as you need it. So that's horizontal pod autoscaling. Now, that works as long as you have room in your cluster. What happens when your cluster becomes full? And so now there's another level sort of that sits besides this, which is cluster autoscaling, which is adding or deleting nodes to your cluster based on how full your cluster is. This gets more complicated because in general, there's not a standard way to represent adding a node to a cluster. It's the type of thing that you'll see, you know, if you're using something like a GKE or an AKS, they'll have their own bespoke APIs that are specific to that service for being able to actually grow and shrink the cluster. Now, one of the things that we're doing in the community is we're moving towards this model called Cluster API that Walid put in the comments here, which is really about using Kubernetes patterns to be able to manage Kubernetes itself. And so in that case, that gives us the tools so that we can start doing a cluster autoscaler that is much more applicable across a larger range of scenarios. And so I think that's a really interesting application that we see happening with Cluster API. And it's one of the benefits of Cluster API, where we move cluster autoscaling from being something that is tightly coupled to the underlying management framework that you're using to something that can actually be applied generically across a whole bunch of different providers, regardless of where you're running, whether that be vSphere or public cloud, or if you have some sort of metal as a service that, you know, you can, you know, automatically add, you know, new Raspberry Pis to your cluster. That's going to be the type of thing that we want to be able to enable with Cluster API. Okay, but the problem that vertical pod autoscaling here solves is actually slightly different. And this comes down to, oh, shoot, sorry, clicking on the wrong thing here. And here's the main GitHub page that we can stare at while I talk here. The, you know, okay, So you're a developer, you have a new application, you need to launch it in your cluster. Okay, when you do a kube control apply of some sort of manifest for a deployment, you essentially run with no limits on terms of the amount of CPU and RAM that you have. And so what that means is that you get best effort. What that also means is that you don't know when your cluster is full, right? Because you can put more and more stuff there, but like at some point the cluster's you're trying to squeeze more into the stuff sack, right? And pretty soon you have more tent than you have stuff sack in terms of your cluster and the workloads that you're putting in there. And so the quality of service and the predictability of your infrastructure goes down. And so there are ways that you can essentially do, what's the name of the object? Somebody remind me, essentially limit ranges, right? Where you can say, hey, everything that goes into this namespace has to have a set request or limit for CPU and RAM. And then along with that, you can actually set the default in terms of what you want the default to be. But now we're in a situation where you walk up to a developer and you say, hey, you're launching this program. How much RAM does it need? And most developers, most application teams are like, I don't know, 10 gig, right? I mean, they just guess, right? Because you have to build experience with understanding what the qualities of how this thing runs in production before you can intelligently answer that question. And so, you don't want to be bothered, so you tend to overestimate, which means that your cluster then ends up reserving a whole bunch of resources for things that may or may not need them. And that leads to essentially low efficiency utilization of your cluster. Or if you guess too low, then the thing just continually restarts because it actually runs out of memory and gets hit by the killer. And everything needs 16 CPUs and a whole boatload of RAM. And so that's the situation that we're in. And so the real question here is that how can we help application teams be intelligent about setting the limits and ranges that they have for, and Java ends up being a whole separate situation. We'll actually get into that a little bit. So how do we help developers intelligently go ahead and pick the amount of RAM that they need with this one? At Google, this is something that Google hit early on. And, it used to be a full-time job of tuning the amount of RAM and CPU that you had, because you're also existing in a world where you have a certain set of quotas and you don't want to run out of quota. And if you request more quota, then that comes out of budget. Because, at the end of the day, this is real money that we're talking about when you're actually reserving this this RAM. And so we had this system that was built out of this team in Poland called Autopilot. And this helped with autoscaling both in terms of horizontal and vertical autoscaling. But I think the most interesting thing for me was the way that Autopilot did vertical autoscaling. And so just recently, Google released a paper on this, which is workload autoscaling, that talks about the feedback loop that they use to be able to set those limits and requests, or the equivalents in Borg, to be able to go ahead and make sure that you can intelligently tune the amount of resources that something needs, which is super cool. And so here's the detail of how that works. Now, one of the things that Borg can do that Kubernetes can't do is change the limits on a workload, how much RAM, how much CPU it gets, without restarting that process. And in doing so, what that means is that Autopilot can actually make adjustments in real time without having sort of the disruption that you would get with something like Kubernetes. It's impossible right now to change the limits in the requests in Kubernetes without actually going through and restarting the pod. Now, we can definitely say that scaling down a workload is always safe, right? There's always going to be room on that machine, and you can always scale it down. Now, it may be that you scale it down so much that the thing ends up running out of memory and bad things happen, but from a sort of containerized point of view and from a scheduling point of view, you can scale things down. From a scheduling point of view, scaling things up becomes very, very much more difficult, because not only do you have to go ahead and scale things up, there may not be room on that machine, and you have to coordinate with the scaler to be able to, the scheduler to be able to make sure that there's room to be able to do that. And so that's something that Google spent a lot of time to be able to do, is dynamically change the parameters of a job without restarting that job, or a task, I'm sorry, without restarting that task. But that's something we don't have in Kubernetes, at least not yet. And I think, nobody's adverse to doing sort of dynamically setting requests and limits of pods in Kubernetes, but I'm not aware of any efforts to really get going with that quite yet. So that's that. So interesting paper. I have some in the notes here. I have some links to some analysis going on here. Michael Gash has a Twitter thread where he goes into some of the things that he finds interesting about this, which is really cool. And then Cindy also has sort of her impressions of this with some of the highlights that she has. She doesn't go into quite as much detail as Michael does in terms of the analysis there. So definitely check that out if you want to start reading up on sort of the autopilot paper and how this stuff was solved at Google, and some of the pros and cons and learnings and pain points there. So that's autopilot. All right, so here's what we're going to do. We're going to get VPA up and running. We're going to look at it in a suggestion mode where it actually says, hey, based on history, here's what I think you need out of this thing. And then we'll see if we can play with turning it on where it automatically restarts stuff. The other place that we can explore is that there's this dashboard from the folks at Fairwinds Ops to be able to essentially visualize the suggestions that are coming out of the pod autoscaler, the vertical autoscaler. Cool. All right, you all are having a great conversation there. One of the things I do want to actually make a call out is to, there are some notes here that George was nice enough to collect for us of sort of this is all done with SIG Autoscaling. And so they have their own meetings and community notes. And if you want to get involved in this stuff, that's the right place to go to actually get the nitty-gritty details. All right, so that sets things up. Let's go ahead and start going on. So the first thing you see here is that when you look at vertical pod autoscaler, it actually goes and starts looking at this stuff, and it says, okay, the first thing you need to do is have a metric server, which we don't have by default. And so now we have to, we're yak shaving at this point. The metric server is a way to actually collect data from your Kubernetes job and make that available via an API that's standardized across Kubernetes, such that we actually have the right feedback mechanisms for things like the vertical pod autoscaler. And let's see, I'm trying to read. All right, so yeah, you all are going deep into Java. All right, let me just say like my take on this, and I'm sure there's a lot more going on in the comments if you all want to take a look at that, is that Java has its own idea where, like, when you launch a JVM, you give it a certain amount of memory, which is its heap. And the bulk of the memory that a Java process uses is there. There's always a bunch of stuff that is not part of that is outside of it, right? Especially if you're using other libraries that are not part of the Java heap via a JNI. But in general, what you find, though, is that the amount of RAM or the pressure, the GC pressure that's happening inside the JVM is somewhat disconnected from the amount of RAM that the system sees that the thing is using. And so, I think to make that useful, you have to actually know that it's a JVM and start getting statistics out of the JVM so that you can make intelligent things based on GC pressure of the Java heap versus having to actually be able to say, well, how much memory is this process using? Because Java is like, oh, I get 2 gigs, I'm going to use 2 gigs. And so that is an interesting thing to actually start digging into there. And I think there's a lot of discussion there that probably goes into a lot deeper than what I'll cover. All right, and so the metric server is essentially another server that you run. It's an aggregated API server that then uses some other system to be able to actually find information about pods and then be able to populate those things up. And so Yumo here says that I found a tool for installing the metric server. I was just going to do this stuff here. Components.yaml. Let's go ahead and give this a try and see what happens. What do you say? And Duffy did the hard work of actually figuring out what are the things we need to know to get this working on kind, because kind is always a little bit different here. So what we have here is, actually, let me go through and we'll look at what's going on here. I don't want to go too deep on the metric server because I want to make sure that we have enough time to really dig into vertical pod autoscaling and really sort of push it and see what it does for us. So let me go through and do a curl-lo of paste without new line. Let's do that. Okay. All right. And the L says follow redirects, and the O means save it based on the URL name. So we should have a components.yaml now. I'm going to move components.yaml to metrics server.yaml. And then we will pull that up in VS Code and take a look at it. So we have a, okay, cool. All right, so we have a cluster role here, which allows this thing to essentially see metrics. Okay, so this is a cluster role for people who want to get access to the metrics server. So it's a way that you can have a standard role definition. And Ajay says, metric server runs as non-root user in the latest release. Oh, that's super cool. Very cool. All right, and then we have a role binding of this. So we have in Cube System, we have a metric server that gets access to that. And then there's the a role binding of metric server into its API authentication reader. All right, so I'm not going to sweat the details here. And then this is the API service. I don't know if we've covered this in a TGIK. This is a way where essentially you can extend the API server in Kubernetes, not through CRDs, but essentially viewing the API server as a proxy that does some level of processing, and then for certain types of resources, forwards it on to essentially a sub API server. And that's what's happening here with this API service here. I haven't actually gone deep on this stuff yet to play with it, but this is what's going on. Here what we're doing is we're saying insecure skip TLS verify. When you set these things up, you want to be able to actually make sure that the communication channel between the API server and the aggregated API server, the sub API server, is secure. That means minting certificates and actually making sure that they all work back and forth. That's a pain in the butt. It's hard to install by default through YAML. And so oftentimes, at least for demo purposes, we'll just say, hey, skip the TLS stuff going on here and just, allow self-signed certs as you're doing this stuff. Now, this is like going back to the zero trust stuff. If we did have an underlay of something like Spiffy and Spire here, then that's something where these things could, say use role accounts to be able to automate, service accounts to be able to allocate this stuff automatically. We're not there yet. I would love to see it be streamlined so that when you're running example code like this, you don't have to have things like insecure skip TLS verify. So there's a service account. There's a deployment of the metric service. This thing is a single one. And then there's a service for that. And then there's a cluster role for that where it gets a whole bunch of information that it can get, list, and watch. And then it gets access to that. So this seems worthwhile. Does this have, okay, so one of the things I want to do is, so the metric server can actually, that API can be serviced from different things. So there are ways that you can, say, use a Grafana backend to be able to populate this stuff. If you look at the metrics server design, let's see. I think it was using CAdvisor in the past, and it's not anymore. I'm not sure exactly how it's getting the data under the covers here. Container runtime must implement the container metrics RPCs. Okay. Yeah, so now the idea is that there used to be this thing, CAdvisor, that would run next to Docker to be able to actually surface this stuff up. But now the idea is that the container runtime can actually surface this stuff up directly. And so this is now, I believe, part of the CRI that we expect container runtimes to be able to use. All right, let's let her rip and see what happens here. Kapp-a metrics server, and then -f metrics server.yaml. Oh. always forget. Kapp apply. Help. Oh, it's deploy, not apply. All right. So this is good. And let me, I think if I go, yeah, it's too small. All right, we'll go back up. It's a little bit confusing. So this is kapp. I don't know if you all have seen this before. It essentially gives you a summary that I just went through when reading the YAML. It actually helps us go ahead and do that automatically here. And we can see that it's installing stuff, across the cluster and kube system. I really like seeing this view. It gives us a good idea of what I'm about to do. Let's see. So let me go ahead and hit yes here. We'll go ahead and run this. And it also actually sort of like can run a bunch of stuff and deploy it in parallel, understands the dependencies across these things, and gives you a nice update as you go in terms of what's happening. And now we should be able to go and look at something like Octant. Let's see what's going on. Is this working? Okay, we can go and we can look at kube system. And we should see the metric server. Where's deployments? There we go. Metric server is running, which is sweet. Okay, so we're up and working. It's running on one of the things. So if you're running this in production, the way that I have my kind server set up is I have 3 nodes plus a master node or a control plane node. So kube control get nodes. In addition to fixing that TLS stuff, this might be the type of thing that you want to run on your control plane node instead of actually letting it float on your cluster. Especially if you're making sort of like closed loop decisions in terms of feedback loops like autoscaling. Cool. So we can go through and this thing is up and running, which is great. And ideally, one of the things, so what is the right way that we can actually test this stuff out? I know that there's integration with the, the Kubernetes dashboard, which I don't have running. I don't think we actually have, that integration with Octant, but that actually would be a good thing. And the design question, like this thing is, I don't know, like, can we do kube control this? Okay, so now the other thing I have here is I'm actually gonna, I have a quard thing, so workload that we can actually play with here. So here's quard. I want to run 4 of these things. This is something I wrote for the Kubernetes up and running book. I haven't updated it in forever, but like, here we go. We can go ahead and deploy this. So we can do quar. Okay, we'll go ahead and deploy that. That's up and running. So now if I do kube control get pods, if I go through and let's see if I do a describe, does that actually pull in? No, I don't think this pulls the metric stuff in, does it? Oh, top nodes. Okay. Kube control top pod. Okay, this will actually. Oh, metric's not available yet. Uh-oh. Something went wrong. What went wrong? All right, let's go through Octant here. The metric server. This thing's green and running. Oh, you know what I did? Duffy gave me all the cheats to be able to actually fix this, and I didn't do it. So I bet you if we go through and we look at this pod and we look at the logs, it's saying unable to feb, no metrics. So it's like it's getting errors because it can't scrape because there's a certificate error going on. Duffy told me about this, and I didn't listen. So... my bad. And Steve's saying it takes about 5 minutes to actually get up and running. Yeah, but we're still getting errors here. So what we have here is Duffy actually put together the changes that we need to make to that. So let's go ahead and do that. So this is in the metrics server deployment. I need to actually say, okay, here's how we actually find the address type that we use to connect to the nodes, and then the fact that we want to do insecure TLS as we do that. So if we look at metrics server here, the deployment here, we should be able to do this. And now we should be able to do kapp. And this will say, hey, I'm going to do an update. So that's up and running. So the metrics aren't available yet, but hopefully if we go to Octane here and we look at this thing and we dig in again, all right, it's thinking. Kapp. Okay, so kapp. I did a TGIK on kapp and YTT a while ago while we're waiting for this thing to do. So K14S, and we're actually going to rename this because it's a crappy name. But kapp is essentially a deployment tool that I really like. It gives you kind of a little bit of a Terraform-like experience as you're deploying stuff versus kube control apply. And the other thing that it does is it has a really rich set of options for essentially ring fencing your application. So you can go through and say, hey, I want to install this stuff, but only ever let it touch stuff in this namespace, which is a good way to make sure that, you know, that you don't have a manifest that looks fine, but then somebody sneaks something else in there that goes ahead and sort of like reconfigures your RBAC rules. So you can sort of ring fence what's happening here. So yeah, super, super interesting. It'll do diffs and stuff to help you out here. And so I think that this is a really great experience for being able to deploy YAML. So ring fencing would mean like, let's see, if we look at the, we'll look at the docs here. Apply. Give me a second here. Integrating with other tools. The deploy command, okay. Deploy. What the? Okay. Does it have the flags here? Okay. So what we'll do here is if we do kapp deploy help, what you can do, the flags are just because I have the font, you know, jacked up so much, is that you can do things like what you want to wait for with a timeout. You can filter and say like, well, I only want to filter this kind or this namespace or this namespace. You know, you can say, hey, I only want things in this particular namespace to actually come in, that type of thing. You know, you can actually set allow namespaces so that, you know, if trying to do something outside of a namespace, it actually fails, that type of thing. So there's like, yeah, all sorts of ways to essentially constrain what it does so that you can say, hey, this YAML that I'm applying, I want to make sure that it stays within this set of constraints. Okay, so let's see if we have, if top works now. There we go. Cool. Okay, so we have data, lot of room here, and we can do top pods. And here we can see, here's how much memory we're using. And we can do a port forward here to one of the Quar-D pods. Connect to that. When I do that, I can go through and I can say allocate 500 megabytes. And so now this thing is just allocating 500 megabytes. Let me shut down that port forward. I can now look, and after this thing does a scrape, how often does metric server scrape? Do y'all know? Eventually, you should be able to catch up with this and actually figure things out. we'll go through and look at logs here. Okay, it's not saying anything, which means that everything must be good. But I don't know if there's statistics in terms of like when the last time it scraped and stuff like that. That'd be an interesting thing to be able to get to. But if we go through, there we go. Now it sees it, and we're good to go. Okay, like about every 30 seconds it'll do a scrape. And then you can see that it's using more CPU cores also. One of the other things that we can do with Quardi is, and so when you do a port forward to a deployment with a whole bunch of pods, it just picks one and goes there. So it's like, hey, they're all equivalent. We ended up getting the same one this time. The other thing we can do is that we can go through and keygen. Oh, this is for doing, I don't know if I have just general. I don't think I ended up doing general enabled. I think this will just pull from a queue. Oh no, it's starting. Okay. So this is going through and it's just generating 4K RSA key pairs, which is a good sort of synthetic workload, or at least a asynthetic workload. And so, so now we'll let that run for a little bit and it should show up as CPU cores as we go. Okay, Aman, you're asking, I'm a complete newbie and need some help. Throw some questions and we'll answer them for you if there's stuff that you're confused by. I know I'm moving pretty fast here. So hopefully we can help get you going. And so Jack is asking, I'm running Kind locally under Mac OS. I'm running a Docker for Mac is what I end up using. So it's Kind running with Docker for Mac. And so, yeah. All right, so now we see this is essentially eating a core, right? Just doing stuff, hitting it hard. Okay, so now we have the metric server up and running. That was relatively painless. Thank you for that gist that you sent along, Duffy. That's super helpful. And so let's go through. Oh, this thing is upset because it got disconnected. And we will go back. And now that we have the metric server installed, we can actually look at the vertical pod autoscaling because we have the history there that we can actually take a look at. And so what we can do here in the install command, okay, there's a hack vpa up.sh. Let's go ahead and I haven't actually gone through and let's go ahead and grab this particular repo. Git clone. So yeah, we're downloading. Very nice. Okay, so now we can go to Autoscaler here. And this should be under here. And it's hack. And let's see how deep into the bash hole we're actually going. Vertical pod autoscaler. Well, I don't see. Okay, what were these things called? It said hack VPA up is what we're doing. Oh, inside the vertical pod autoscaler directory. Hack VPA up. Okay. VPA process yamls.sh, which goes through, creates a bunch of components, and is going to create a whole bunch of YAMLs. All right, this is what happens. And then it does a kube control create on this stuff. Okay. And then this thing is actually going through and, okay, this is doing things like generating certs and stuff to be able to do stuff for the admission controller that it installs. And so it's going to be creating the CRDs, the RBACs. So this is one of those things where I would prefer, if this actually were to create a bunch of flat YAML that I could actually go ahead and apply. Because what we see here is that we're essentially processing these things and automatically there should be a deploy folder. Okay, I'll take a look at this because this is generating certs and stuff and doing a bunch of sed to be able to actually sort of make this stuff happen. And then the deploy folder. Okay. Now, is this doing the sed stuff for like the certificates and stuff? We'll have to see. Okay, so let's see. So this is process YAMLs. So this is going through and actually updating the registry tags with the default registry, and it's going through and calling gen certs and okay. All right, so this is a little bit wacky. Okay, package, mission controller. Well, this thing is like, oh, I see, okay. There's a gensearch.sh. So this is generating the certs, putting them into a temporary directory. Oh, and then this actually uploads them to the cluster then also. Okay, so let's go ahead. I'm comfortable with that. Let's go ahead and see what's happening as we do this. The set of things that we're actually creating here are the CRDs, RBAC stuff, the updater, recommender, and admission controller. All right. So that seems simple enough. RBAC, I assume, gives you some sort of routish type of thing going on there. And then it has to be able to create the right sort of TLS stuff so that we can install the admission controller. So there we go. So let's just go ahead and let her rip and see what happens. Hack CD. Oh no. CD vertic. CD hack. VPA up. Oh. Uh-oh. Add ext. So, all right, so here's what happened here is that I'm running a Mac OS, and it probably has OpenSSL version is 283, which is LibreSSL. I wonder if it's missing the add ext thing in the certificate. This is like the type of stuff that most people give up. So we're trying to do a subject alt name. DNS. Okay. New key. Extensions. It probably is a different. Okay, syntax. LibreSSL add. So look, I'm not the only person. Oh look, and so this is actually an issue that was closed. It'll be available in the next release. So it's just that I'm only running an old version of LibreSSL. Yeah, I know. So brew search Libre OpenSSL. Installed, which OpenSSL, user bin. Okay, so brew link OpenSSL. Refusing to link Mac OS. If you need to have blah, 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 then I have to be able to do this. Okay. So we will add this to our path temporarily here. And then we're going to go through and call this again. And it was able to generate the certs. Okay. Yeah, we could do LibreSSL, but the script was still calling it with the OpenSSL name. And so then we'd have the LibreSSL thing in. So I think part of the problem here is that Mac OS has LibreSSL installed as OpenSSL, which really confuses things. So I think, we're in decent shape here. A lot of this stuff we called create, but it already exists versus apply. So now if we go ahead and look at Octant, we should see that custom resource definitions, we have the vertical pod autoscaler checkpoints and vertical pod autoscalers. Okay. And then in terms of, let's see, across all namespaces, what do we have? We have probably in Cube System, we have deployments. Here's the admission controller, the recommender, and the updater. So it looks like, oh wait, the admission controller is pissed. Why is it mad? So it's pending. Logs, no logs. Is there a way to actually get... Oh, I think... It seems like maybe... Why is it pending? Okay, is it in a crash loop? Pending. Container admission controller. Has the volume. Okay, so this is the deployment. Let's actually go down to the pod. Why is the pod pissed? Oh, it's because the secret wasn't there. Got it. Okay, because that secret didn't generate, that meant that the pod wasn't able to start up. And so there we go. All right. So I think... Okay, so I think we're up and running now, and we have the vertical pod autoscaler. Everything is green here. I shouldn't have to hit the reload there. Okay, cool. So now let's actually see, like, oh. Yeah, here's that error that I hit. If you see the following error. All right. After installation, the system is ready to recommend set resource requests for your pods. In order to use it, you need to insert a vertical pod autoscaler resource for each controller that you want to have automatically compute resource requirements. The most commonly is a deployment. And so there are three modes: auto, recreate, and initial and off. So we probably want to do, let's start with off here. And here's an example. So now what we'll do is we'll go here and we have this thing up and running. I'll look at QuarD, and what we're going to do here is we're going to insert this new YAML, which is autoscaling.k8s.io, vertical pod autoscaler, name, QuarD. Okay, version apps v1, deployment, name, QuarD, update policy, and we were going to start with off, just automatically sort of make sure that we're in good shape. Sound good? And so now we can do, let me, and we'll do a kapp. Oh, did I not save this? Okay, why is this QuarD.yaml? Oh, yeah. So now what it's saying is we're going to create the vertical pod autoscaler. There's another thing on kapp, which is essentially kapp deploy. And we can go through and wait flags. this is the one this makes me feel better, is that show changes namespace. There, I want it to show all the resources, even the unchanged one. Show changes. Apply. I thought there was a flag to be able to do that. Namespace string app. Sorry, stay with me all. Resource filter, resource validation, resource mangling, available other flags. Labels, patch, sort, global flags, debug. Huh. Oh well. Because now we go ahead and do that, and it's going to create the vertical pod autoscaler. We're good to go. Now if I go back to Octant and I look at oh, and we want to go into the default namespace, and we can do custom resources, and here we have the QuarD vertical pod autoscaler. And this thing is up, and there's a whole bunch of stuff they got applied there. So we have a spec. Nothing's getting updated yet. All right, so we have that applied. Okay, so now what it says is let's go through and test your installation. And then describe VPA. Okay. Cube control describe. Cube control describe VPA QuarD. Let's see if that works. Okay, here. All right, so this is cool. So what it's actually saying is it's saying, well, lower bound that we see is, 260K or 260 megabytes and 25 millicPUs. The target here is really a lot bigger than that with an upper bound. So it's like, so these are the suggestions that it's giving. And remember that, like, we have 4 of these pods running. One of these pods is really hot. The other 3 pods are actually pretty idle, right? If we do top here, we'll see that this thing's still running hot. And so these are like what's going on here. I'm wondering what, lower bound target, uncapped target, and upper bound, what the sort of explanation there is. So let's read through a little bit here. So the recommender, okay, so here we have, the recommender, the updater, and the admissions plugin. So we're just using the recommender right now to be able to deal with this stuff. Capping to a limit range. All right, so okay, so that's cool. So now what do you say we just let her rip and we go through and we do the we do auto for the thing? Does that sound good? And see what it does. Okay, so now, all right, let's make sure that we have Octant ready to go so that we can actually see this. We'll look at the deployment here for QuarD. And here you see we have these things running. And it doesn't talk about resources going on there, but there's no restarts, no nothing. It's all running. And we actually see it's BB4 is the name of the replica set. Yeah, we always YOLO, all right? So now we'll actually go through and we have it on auto. We'll do kapp deploy. We see that this is an update. I think we can give it a -C for like a diff. Yeah, and you can see here it actually shows you what's going on here. Oh, this is probably something that you have to keep in mind here. If you do, this is YAMLisms. This is bad. So if we say off, you're like, oh, that's the same, right? But no, YAML off is actually interpreted as a Boolean. And so this is different from that, right? This is a string. This is a Boolean. So this is a semantically equivalent of saying false here, right? It's also the same as saying no. which if you're using two-letter country codes and you actually two-letter country codes and you're talking about Norway, that'll get you in trouble. So we want auto doesn't need to be in quotes, but off does, right? So just make it a good habit of, like, you know, putting this stuff in quotes if there's any chance that this stuff will happen. You know, what I really want to do is I want to create a dialect of YAML that removes all the wacky. And I'm not sure like what that would look like, but I want to do like simplified YAML because I'm not ready to yeet YAML completely yet, but I think there's a lot of features of YAML that we got to yeet. What is CDK Kates? CDKates, is that the YAML? Because there is the configuration SDK that AWS has, but I haven't had a chance to look at. All right, so now did we apply? We're not applied it yet, so let's go ahead and apply it. And at some point something will happen. Let's see if we see it happen. Okay, the CDK stuff, I want to check that out at some point. Maybe add a TGIK episode ID on that. That might be fun. All right, I'm not seeing much happening yet. Let's revive Case on It. No, I like Case on It. It was just too deep, too fast. I do like Q. I did a TGIK on Q, and I think, you know, there's a lot of great sort of shared ideas across those things, and there's a lot of folks that are excited about Q. Oh, there we go. It's actually going through and actually adjusting things and restarting it. And we are off to the races. So now, if we look at the resource viewer, or the YAML here, what we can see is that initially we did not have, if I can find it here, spec, template, let's see. I would expect to see, am I confused here? So this thing is up and running and working. Oh, it didn't set resources to it, but it restarted some of them. Oh, is it doing a rolling update? Deployment. Okay, Ajay, let's take a look at this while we wait for this thing to settle. Definitions used in the recommender. Ah, cool. Okay. So, okay. So target, the recommended CPU request and memory request for the container. The minimum, this amount is not guaranteed to be sufficient. The maximum, and then the uncapped, the most recent. Okay. So let's see what's going on here. Did it actually, so what I would expect to be happening here is that this actually goes through and modifies the template on the container to actually add, well, not to add resources here, or resources in some ways, but I'm not seeing that there, which is confusing to me. Describe VPA, yeah, okay. Yeah, so here we are, and lower bound, target, and uncapped and upper bound. What's going on here? All right, so let's go through and let's see if we can figure out what's happening here. So this thing happened. Something caused it to restart. Oh, it is restarted. Oh, you know what? Did it actually go through and edit the pods directly? Oh, ha ha ha. All right, so that's a little bit not what I expected. Yes. Okay, I get what's going on here. So, okay, I understand the flow. So if we look at the YAML here, what we'll see now, here we actually see the requests. We actually have the request there right now. So the way the flow works, and this was something that I think I was a little bit confused about, is that the recommender actually figures out, here's the recommended resources. And then and then there's the component that actually goes through, and if the recommendations aren't good enough, then the updater actually just goes through and actually has criteria that says, okay, let me go ahead and whack these things. And it's similar to the rescheduler for the scheduler, okay? And then that relies on the admission plugin. When the deployment actually goes through and recreates the pod, it relies on the admission plugin to actually go through and during the admission cycle, actually add those recommendations to the pod as it goes. And so what that means is that nobody is actually modifying the deployment directly. Instead, they're actually only modifying the pod, and they're modifying that out from under the deployment as things go. So that, I think, is what's going on here. So yeah, so Li Lang is right there, that VPA will not change the deployment YAML, but the pod directly, which is definitely pretty interesting. Okay, so that's pretty cool. So now we can go through, and this thing got restarted. And okay, so a couple of things here is I don't want just recommendations. I want this thing to set limits also. So can we go through and can we actually say limits? Okay. Container controlled value request in limits only. So this is in controlled values, container resource policy, pod policy. Okay, so let's see if we can dig into that, because I want this thing to actually set both. And is there documentation on that? Keeping, okay. Container template specifier request, blah, blah, blah. Capping to limit range. Resource policies. Okay. This is not the best documentation. Okay, so resource policies is what it's called. Resource policy VPA. Okay, does Google have documentation on this? Well, that sucks that Google doesn't actually go through and actually support moving this documentation into the Kubernetes documentation. You'd think that they would be better if they actually made this documentation on kubernetes.io instead of GKE. All right, so we can go through and so now what we can do is in the pod autoscaler, this is still pretty obtuse. Okay, update mode, container policies, container resource policy. Okay, so now that's not under, sorry. Okay, so this thing has a pod update policy spec. Okay, so it has update and resource policy. Okay, so we have to do a resource policy here. And then the resource policy is a pod resource policy. And then the pod resource policy has container policies, right? And this is an array. And the container policies is that we have the container name. If not specified, the policy serves as the default policy. The mode, okay, so you can turn it off on a particular one. And then Minimum CPU requests, memory requests allowed, and the maximum. Okay, and then what do we have? We have, so I'll get to that sort of like, we'll test out some of the edge cases here and see what happens here. Because I think uncapped target, autoscaling condition. Okay, there's conditions that actually report it also. Okay, so recommend container recommendation. No, these are all in the status. Okay, wait, but this pod update policy, pod resource policy. Okay, and then we have resource policy, container policy. Okay, and then we have mode, container name, min allowed, max allowed, controlled resources. You can do CPU and memory, and then controlled values. We want to do requests and limits as the default. Okay, so requests and limits is the default. Then why? What do you think? Think that'll work? Oh, container name is required, but it said container name. I guess we can just do star there to say. Okay. So, yeah, so the pods get restarted. Okay. Does it do downscale also? I don't know. That's a good question here. Let's see what we're at here. So now what we can do is we can do, let's look at the describe of the VPA, recommendation, events, condition, last transition time was 2106, status true, recommendation provided. And so there we have here, now we have requests and limits going on there. Okay, so let's go through and let's test this out and try and stress it a little bit. So now if we look at the summary here, created, all right, so this thing was already, it got recreated, and then the, okay. Ooh, this is cool. I didn't know we could do this. This is inside that container. What? Okay, that is a cool feature of Octane. I hadn't played with this yet. Like, if you go to a pod, you can actually go through and automatically easily get a terminal inside of that pod from Octane. That's pretty awesome. Okay, so are there logs for the admission controller? Yeah, that's a good idea. Let's go ahead and take a look at that. So what we can do is we can look at Kube system. We can look at deployments. We can look at the admission controller. And we can look at this thing here. And we can look at logs. Okay. And here is processing VPA, kapp. Oh, there's a whole bunch of like, it's pretty chatty in terms of how it does this stuff. Watch closed. Recommendation provided, true. Okay, so this thing, it looks like recommender update, and then there's just fields raw. That's not super useful, dudes. Pain in the ass. Yeah, why? I don't see it being, okay, this is not super useful. It says that I recommended something, but it doesn't actually say what it recommended and why. So this is the admission controller log. All right, so like now if we go and if we look at, let's look at the, what are we looking at here? Cube system. Oh. Now let's look at the recommender, the updater, see what its logs say. So when does it decide? Not updating a short-lived pod. Request within recommended range. I see. Okay, so it has a range, and it's like, hey, if it's within this range, whatever, I'm not going to do anything. All right, so now what we can do is we can do the port forward. And so what I think you can do is that if it's outside of that recommended range, then there'll be the thing that'll go ahead and kill them and actually let the controller actually go come through and update things. And so there's probably parameters that you can use to say, like, how wide do you want that range to be versus where it's at versus where it's been. And so now if we go through and let's add, we'll add sort of like, so this thing's now taking 2 gigs of RAM. And this thing should take 30 seconds or so to update. Okay, yeah. Oh, it says 1.6 gigs. Huh. So Mahmoud says, for CPU, the objective is to keep the fraction of time when the container usage exceeds a high percentage, 95% below a certain threshold. Yeah, so this is, I think, an interesting thing is that you're going to get spikes in CPU. You don't want to necessarily set your limits based on those spikes because CPU is fundamentally compressible. Memory, on the other hand, is not compressible. And so what you want to do is you want to allocate more memory than you think you're going to need. Because if you run out of memory, then you get killed by the killer, and that's bad news for everybody. And so that's a different sort of criteria that you're looking for as you're doing this stuff. Okay, so now we can do the keygen workload, and we can enable this here. And now that'll actually start pounding away at this stuff too. All right, so we have this thing up and running, and at some point the autoscaler here, this will be the updater. It says, it says not updating. That was just recently because it's short-lived. Yeah. Okay, so, okay, there we go. It's taken a while for top to actually sort of catch up with the stuff. So I think one of the other things to keep in mind is that with systems like this, you don't want them to move too fast. And so it's kind of hard to demo, but you really want these things to be sort of, work at their own pace because, they're pretty powerful. If you go through and start killing all the pods in your system because you're trying to tune the resources, it's easy for that stuff to get out of control. And so you really need to sort of make a change and wait and see how things settle. And so the name of the game here is really one of being patient and letting the system work over time versus trying to actually make it work on sort of a scale that we want it to work on. And so it can often be frustrating when you're dealing with these systems because it feels like they're not reacting slow enough. But in reality, from a control theory point of view, we want this to be a highly dampened system. It's okay if resources are not well used for a while, if eventually sort of things converge where you want it to be. That's kind of the thinking behind the same things when you're doing updates and stuff like this. And so it looks like it wants to make sure that the pod is alive for a certain amount of time before it decides that it wants to go ahead and kill it and restart it. So we'll let this thing go. I am confused in terms of why it's not setting limits on the thing. So one of the things that we can do here is we can go through and cube control, delete, deployment, quard. So we'll just kill quard. Okay, so we're using the VPA is still up. Oh, and then my port forwarder is upset. Okay, the VPA is still there, but the actual things that it's referring to are not there anymore. So Vivian, you said the VPA does not set limits, but then there was a parameter there saying that it does set limits. So I'm wondering if maybe it only sets limits if you already have limits set. Because I was expecting it to set limits. Okay, so now what we're gonna do is we're gonna deploy quard D again. Okay, and here we are. We're gonna create the thing. So now the admission controller should be applying, and when we actually look in default deployments, and if I look at one of these things, oh wait, why didn't bot. I would have expected that this would have actually gone through, and since I recreated the thing, the admission controller would have set things. You know what? Is it because I don't have any limits on the thing itself? Let's go and try and set that up. Okay. So resources, and I always forget the syntax for this. Kubernetes set resource limits. I'm just like the rest of you. I look this stuff at Google every time I want to do stuff. Okay, so limits and requests. Okay, limits CPU 1,000 millicPUs, right? And then memory 1 gigabyte. We'll just do that. Does that sound good? So we'll go ahead. Oh. What is it mad about? Must match. Oh, I have to capitalize stuff. Milli means small. This has to be a G. All right, so now if I go back to Octant and I look at one of these guys, what we find is that, okay, limits are set and requests are set to the same as limits, but it actually expanded it. It added to it based on the history of the recommendations that were going there. And so, okay, so this is the admission controller does different things depending on whether you actually have resources set by default on that thing or not. If there's resources that are set, they can be set via limit ranges or directly. It looks like then it'll actually adjust them, but it doesn't automatically set things for things that aren't already set. Maybe there's a configuration around that. So now it sounds like what I can do here is I can do my port forward. And the amount of RAM is it's like 1.2 gig. And so if I go through and in memory here, 500, 1 gigabyte. Now, the next time I hit this, it'll probably kill the pod because the yeah, so the thing died. So if we go back to Octant and we look at pods here, let's see, this thing restarted, created, or no, one of them restarted. Which one is it? Restarts? No. Okay, what's going on here? Oh, let's hit it again. I would expect that this thing would die because it's actually violating the limit. There we go. The killer got to it. All right, so one of these things, this has a restart. And then something actually went through and deleted it. And it looks like, oh yeah, look at that. The memory limit got up. So this is actually really interesting, is that I'm not sure exactly what's going on here, but the killer killed my pod and it restarted. And it seems like the vertical pod autoscaling is like, ooh, let me go ahead and increase the RAM here. So it actually set that pod to be bigger than what had been there before, to make sure that we don't get in a sort of restart loop because it's too slow to react to something running out of memory. So it seems like it's very aggressive about ratcheting up the limit on RAM based on the killer hitting you hard. So if we go through and we hit this again, and now let's go through and we'll take it up to 2 gig again. Maybe. Oh, we got attached to a different one. Okay, so now all right, so now it's dead. Ha. Okay, so we got killed there. And so that one got a restart, but when it restarted, it got, okay, there's the memory limit. So interesting. I wonder what's going, I'm not clear what's going on here, to be honest. But it seems like it's ratcheting up the, all right, let's go ahead and let's take a look at this one directly. And we'll port forward to this. All right, so there we go. So now this one here that we're looking at with Octant, it has, okay, 1.7 gig of RAM associated with it. So like, let's go up to 1.5 and we should be good. And if we go through and top pods, oh, this is still catching up here. Yeah, so now what will happen is that you'll have some limits will be set differently in different pods across your thing based on sort of like when they got killed and restarted. And I think that's probably a choice between updating limits versus the disruption of being able to update those. And so that is that is one of the things you see. Now, if you did this at the deployment level, what it would mean is that every time you updated the limits, you would have to go through and re-roll the entire deployment, which may actually, not only will that, you know, now it's like, oh, if you use your deployment to track which versions you're running and you have a limit on like, oh, I'm only going to track the last 5 versions, and I use the deployment rollback, stuff like that. If the vertical pod autoscaler modified the deployment directly, that would create a lot of sort of, you know, crap or cruft in your deployment history and would make it difficult to use deployment to be able to essentially roll back to the previous version. So it's probably a good thing that this doesn't modify deployment directly, because doing so would actually create that noise in the deployment history. Yeah, so now we're at 1.5 here. Does it add an annotation or event about what pods have been updated? It's very difficult to trace. I agree. I'm not seeing the events here. I would love to see more insight in terms of what's going on, why it did what it did, either a status page separately or writing events into this thing. Because here in the pods, you know, this thing essentially got restarted. I'm not sure where it would leave a breadcrumb around that stuff. We can definitely look at the vertical pod autoscaling for Quad D. What does this actually do? If I look at the YAML here, it has recommendations, and then it has sort of the last recommendation that it provided, status true. Now there was this other object here, and I'm not sure what this is, which is a checkpoint. And what's in this thing? Bucket weights. There's a memory histogram of sort of what it's seen. the number of samples, and then it updates this. Okay, so this is essentially, it keeps a bunch of stuff in RAM, but it writes this into a CRD every once in a while so that if you restart the recommender, it doesn't actually have to start from scratch again, right? Which is interesting. And the VJ says, moreover, if using a GitOps controller, VPA updating the deployment would lead to issues. Exactly. Vpol, I'm running this on Kind, running on top of my Mac, and so it's just a little sort of toy cluster that I can play with. Lamati says, I worry about stuff getting killed that is actively processing traffic and data. Yeah, that's the concern here, is that I think if you have the right sort of like pre-stop hooks and the right the right probes in place, you should be able to do a graceful shutdown, and you should play with that when it's actually doing a restart for setting limits appropriately when you're outside of the band of recommended things. If you hit an situation, it's going to restart you right away. And so there is a higher chance of disruption with things like this, especially if you don't have a good baseline to work with when you're first getting started. But I think the idea is that over time, this thing gets a really good idea of how much RAM you actually need, and it can then go through and just automatically set things without you having to worry about it. And so I think probably you'll see a lot of disruption early on, but as it builds its model, as it actually understands the quality of your code, of your workload, things will be better. It will be dangerous when you do an upgrade, because the first time you do an upgrade, you may introduce new features and be using more RAM, in which case then you have to deal with the situation of like it may restart a couple of times while it actually builds that model and figures out what it needs to do. Yeah, or you can just use it in recommendation mode, right? Which is still useful, right? It's better than nothing to be able to do that. Okay, so now I think we're there. The one last thing I wanted to actually dig into here, because I think it looks really cool, is the Goldilocks from the Fairwind folks. Let's see if this is super easy to actually install or how hard this is. Okay. So installation helm, manifest. Okay, so let me go ahead and actually pull this down. Git clone. CD hack manifest. Okay. And so what it says is, let's go through and cube. Goldilocks. Controller dashboard. Okay, so it's going to create a bunch of cluster role bindings. This is why kapp is great. Did you see what I just did here? And it's going to actually then install deployment service account, deployment service account for the dashboard and the controller into the Goldilocks namespace. And so this is a great sort of like, give me a view of what's happening here. You can do the diffs and stuff that's going on there. We'll go ahead and run this. Now what this should be doing is it'll actually go ahead and set up the VPAs automatically for you, and then read those things and report those things in a nice dashboard. And so let's see if we can figure that out. Okay, we have to enable the namespace to say that we want that namespace to do that. So we'll label that namespace, and we'll also label the default namespace. And then we can view the dashboard. Let's see. Oh. And now, we're getting a page not found. Why are we getting a page not found? Oh, because this is my like wacky thing left over from QWERTY. Namespace Goldilocks. Okay. Yeah, I had the subpath there. Yeah. Okay, so why? It's not showing me anything yet. Maybe it takes time. So Goldilocks. Okay, so it's creating the VPA for you automatically. That's up and running. Yeah, so Goldilocks is essentially a third-party dashboard for showing recommendations, right? So, okay, so this is fascinating. So, okay, cool. So, like, it'll go through and say, like, okay, right now your current is set to 25 and guaranteed is 25 millicPUs. And you're currently using like 32 megabytes, but, you know, you're guaranteed 263. And so, you know, so here's like suggestions for like limits and stuff like that that you can add to your so this helps you to actually say, okay, based on history, here's the recommendations coming from the VPA without having it auto reply. So this is just a way to essentially automatically create VPAs for workloads and then provide a dashboard so that you can actually understand these things and see what's going on. So it's just it's a friendly little dashboard for seeing this stuff, which is pretty cool. And then it helps you to decide whether you want to do sort of burstable or guaranteed. So burstable, it's like, you know, more memory than you'd ever need, whereas guaranteed is, you know, a reasonable amount. So Lamati says, that is pretty neat. Is that specific to VPA or does that work without request limits without? No, I don't think this uses VPA to actually drive and get the recommendations. This is just sort of presenting them in a really consumable way. And it does a little bit more where if you don't have a VPA configured in recommendation mode for a particular workload, it'll then go ahead and actually create those VPA objects for you. And so what we can see here is that if we look in the Goldilocks thing, it went through and created the vertical pod autoscaler resources for both the dashboard and the controller. And then it waits for the recommender to do stuff. And then it essentially takes the information out of this and it puts those into the dashboard. So now we can go ahead and look at the dashboard and you see like, oh, here's the suggested changes that it should be able to make. So it's just a way of actually sort of like turning the crank on this stuff. And I set the one thing that bothers me is that it didn't actually, we labeled the default namespace with Goldilocks enabled true, but it didn't actually, it looks like Goldilocks is not paying attention to it. Okay, so now what I'm going to actually do here is kube control get VPA, kube control delete VPA, because this wasn't created by Goldilocks. Goldilocks may like be like, hey, I don't know what's going on there, and actually, so we'll just do that. So now that QWERTY no longer has the vertical pod autoscaler attached to it. And so let's see if this actually catches up here and see if it actually creates that thing for me. Vivian says, can you check the default namespace for the VPA object? So we shouldn't have, in the default namespace, all we have is the checkpoint that was left over from before. We could probably delete that, but that's okay. We don't need to. We can leave that there. What we don't have is any VPAs right now. But the namespace itself, we have default, which does have the right label on it. So I'm surprised. I don't know why Goldilocks isn't actually scraping the default namespace. All right, that's something that I think is probably get into later. Lemati saying, anyone running VPA in production, curious what the real world experience is like. I don't know if anybody's running VPA in that sort of full auto, full loop mode. I'm sure a lot of folks are running it in the recommender mode, because I think it's a great way to sort of say what's reasonable for this workload to get started. All right, we'll go ahead and check the logs here real quick to actually see what's going on. We'll go to Goldilocks and we'll look at not namespace overview. We'll look at the controller logs, namespace Goldilocks. Check the labels found unsupported value for VPA update mode off. Okay. Dashboard created with VPA update mode off. Error creating VPA. Okay, it already exists, so it's like, I don't know what's going on there. So that really confused it, and it refused to reconcile. And so this was about 7 minutes ago. And so probably what's happening is it's like, well, you already had a VPA configured for QuarD. So like, you know, I don't want to. So what we'll do here is we'll delete QuarD again. Delete the QuarD deployment. We'll do kapp deploy of QuarD again. Oh. We'll just go ahead and that'll install the VPA again. Kapp delete a quar. We'll take those things down. Now we'll go back and we'll go to our QuarD manifest and we'll actually delete the VPA because we're going to let Goldilocks do that for us. So now we'll go and we'll deploy the darn thing again. We're just creating the deployment, not the VPA. And now what should happen is Goldilocks should create the VPA for us. And so let's see if that's actually the case. And we'll look at this in the default namespace. Yeah, so it created that for us now. So now if we go to Goldilocks, now we can say, okay, in the default namespace, and it's still waiting for recommendations to actually show up. Okay, VJ's asking, how does the HPA and VPA dynamic look like? Just curious, are they mutually exclusive? I think they work with and against each other. I think you can only vertically scale up to a certain point. And so probably what you want to do is, if you're using these things together, you probably want to set the vertical pod autoscaler with some maximum limit, like don't go above this certain limit. And I think there's ways that you can configure VPA to sort of say, hey, I don't want any of my single pods to be getting too big. This is assuming that like capacity is actually like you could put it in one big bucket, or you could put in, you know, one big pod, or you could spread it out across a bunch of pods and it's roughly equivalent. Not all workloads work like that, but generally you want to make sure that you don't have any pod getting too big. And then, so you want to do, you know, vertical scaling up to a certain point, and then make sure that you can have horizontal scaling take over after that. But yeah, I think, you know, they could have some weird interactions, but they're both optimizing in different ways. And so I think you probably want to do some testing if you're going to work through them and work with them together. Okay, yeah, so Lilang says like, yeah, you can use them together, but if both of them are keying off of, say, percentage of CPU used or something like that, then they actually get in a race between each other. Yeah. Whereas if your horizontal autoscaler is based on, say, latency characteristics, that may actually work independently to memory and RAM. So Robert says, Cube state metrics will expose some VPA metrics so we can trigger Slack alerts to go manually look at wildly over provision deployment. Yeah, that's good. You definitely want to keep an eye on these things until you get a comfort level that they're doing something sane. And then, yeah, there's the known limitations in the GitHub docs is also really interesting there. All right, cool. So I think, let's see, did we get this? This should actually go through. And once in there, here we have QuarD, and it's saying, okay, currently things aren't set. here's what we're suggesting as sort of like the default for this particular container. Because, you know, I actually had a very simple deployment here. Oh, I did have limits set. Say P. Okay, so yeah, limits are set, but requests are not set. And so here they're saying like, hey, your limits are way too big based on what we've seen so far, right? Because you know, the reality is that what the VPA has seen with this instance has been a relatively calm usage, because I haven't gone in and hit that button to actually scale things up. All right, with that, I think, you know, this has been a super long episode of TGIK, but I've had a ton of fun exploring this stuff and figuring this stuff out. Just real quick, Lamatti's asking, how long did it take me to write QuarD? I wrote it while we were writing the book, and it was an excuse for me to actually build an application that used a combination of React and a Go backend. And so I was learning a whole bunch along the way, had a lot of fun doing it. So you can check out the code there if you want to. It's easy to find. And there's some PRs and bugs and some stuff that I have to take care of that I've been putting off. I need to find some time to give it some love. Yeah, with that, I think I'm going to end it here. Let me switch back to my face here. Thank you so much for joining with me and sticking with me as we've exploring this. I've learned a ton. I think this is a really, honestly, relatively low weight way to get, at least in the suggestion mode, what you should be setting resources and limits to. I think, you know, before you move this into this sort of auto remediation mode, you probably want to be a little bit more careful to make sure that you are, that you know exactly what it's going to do with your particular workload. But from a recommendation point of view, I would say this looks like a really, really useful system to use even now. So with that, thank you everybody that was able to join me, and all the great interactions in the chat. I love seeing that. I wasn't able to follow it all while we were going, but lots of really good interactions there. And so y'all have a good night and a good weekend, and we will see you next week. I think Duffy is probably on for next week. Hopefully we'll see how things shape out. I think he was going to try and see if we can figure out how to have a guest on for TGIK, which would be a blast too. So with that, I'll sign off, and y'all have a great weekend.